Everyone, very good morning.
Hey, good morning, everyone.
Very good morning. As class is yet to start, uh, is it possible that we as students can have a separate one meeting just in order to understand better? Because I can't follow the chat we are having on WhatsApp. So if you guys are okay, we can plan a meeting where we can get along well with each other over a
I
Teams
think
meeting.
after this class now, when ma'am leaves, we can discuss with Simran and all.
Yes, that would be better because it's very much required to have a good networking during this course, even the post of this course.
Also, guys, hi, this is Simran here from Futurance. Just one thing I discussed with a couple of your classmates yesterday that I'm reiterating today since most of you weren't there in yesterday's call. So when ma'am is taking the session, just to keep the class a little bit more structured. So when she's taking the session and in between, she usually asks, do you guys have any questions? That's when you guys raise your hands, and only those people raise your hands who have questions related to what ma'am has taught in that particular section or in that particular subtopic. Any questions that are not related to what ma'am has taught, just make a note of it, and towards the end of the class, ask those questions so that we're not breaking the flow of the class. Is that okay with everyone? So during the class, when ma'am asks if you'll have any questions, those of you who have questions related to that subtopic, that slide, or whatever ma'am has taught, raise your hands. I will probably in the chat box write who goes next, who goes when. Those of you who have questions that are not related to that, but somewhat related to a different concept of something, just make a note of it, and towards the end of the class, we can ask those questions. I hope that's okay with everyone and everyone got what I'm saying. If anyone has anything else to
Right,
say, you can
Simran,
add.
right, Simran. Definitely the
Simran,
best
yes.
approach.
Yeah, that makes sense. Yeah, we are aligned to this.
Perfect. Durga ma'am has joined, so now we can start.
Good morning, everyone.
Good morning,
Good
ma'am.
morning.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning. Very good morning to all of you. And without spending more time, I'll just share my screen and we'll start. Give me a minute. Okay, so we'll just do a quick recap of what we did yesterday, and then we'll start with today's portion. I hope you're all able to hear me and see the screen.
Yes, ma'am.
Yes, we can.
Yes.
Yeah.
Okay, thanks. So yesterday we started out with data pre-processing, and I told you that in data pre-processing we have certain tasks that are usually common across any kind of data, which comprises of data cleaning, data integration, transformation, reduction, and data discretization. So yesterday we started out discussing about how to impute missing values, and there were different options that were discussed. For example, we started out discussing that if the percentage of missing values is very less, then the simplest option could be to remove those particular samples as you are seeing here. Now, removing samples until unless the number of values not having the data in it are very less, this may not be a good option. As you can see here, as the percentage of missing values increases and we remove the corresponding samples, it can happen that the class distribution may change. As you can see here, that earlier it was C1 class 3 samples, C2 class 6 samples. Now, after removing the missing value samples, the class distribution got changed to C1 3 samples, C2 4 samples, which is almost a homogeneous class distribution. And this is very different from the original data where C2 was a majority class. Then the next case we had discussed was that when we have around 10%, that is double the missing value as earlier, then what happens is that, and we are using the same option, that is removing the samples containing missing values. Then you can see here that the class distribution has changed to the limit that the minority class has become the majority class and C1 has become the majority class. And now, certain other variations of this might lead to the fact that one of the classes just could go missing. In this case, C1 is just missing because of removing of the sample. So to conclude, removing samples is not a very good option. Then I also showed you using another example where there were 50 points and 2 variables, X and Y, and a class variable. And this was the natural groupings in the data. And there can be 3 clusters, as you can see here. However, the class label for cluster 1 and 3, which are shown in the dark blue and the cyan colors in the lower portion, are both C0. And the upper cluster, which is shown in the dark green color, is class 1 cluster. And then there are anomalous points also, which are very far away from the normally behaving points that you can see in the red color. And then there are boundary points. Boundary points are those points that are equally, that are at an equal distance with respect to the given set of clusters. And therefore, we need to decide in which cluster we can place them. We can actually place them in any cluster. Then, here in this example, again, when we remove 10%, you can see that the data distribution changed slightly. And the points that have been removed just for the sake of clarity are shown in those pink crosses. And then if we increase the number of missing values to 30% and then remove the corresponding samples, we can see here that the data distribution has started to change to the point that one of the classes is completely removed, in this case class C0, and only C1 is left. So then we also discussed some other options other than removing of samples, which we concluded wasn't a good option. We also had discussed additionally removing of columns as proposed by some of you, though I haven't put that example here, but removing of columns could also create a problem if the column, in spite of having missing values, may contain some important information. So without any background knowledge of what the column stands for and how critical the information in it is, it's not a good idea to remove columns as well. Then there was another option to fill in some default value. That could be anything. I've just shown 100 or something. And then returning to the data example where there were 50 samples. So I tried to create 20% missing values in it, such that the missing values are equally distributed across the 2 different variables, X and Y. And then we tried to fill a default value, say 10, in all those missing values. And then we did the plot. And we saw that a new kind of category is getting created. You can see the yellow stars out there. This is what is the default value points. And this did not exist earlier. However, it has got created. So it is leading to formation of a new class, which is a pseudo class, which did not exist earlier. So this means that filling of default value is also not a good option if the number of missing values is large. Then we also thought of filling the mean value. Here the mean value refers to the mean of the corresponding variable. So you can see the distribution. This is another data distribution I took as an example. And in it, there are two natural clusters shown in the blue crosses and the green squares, standing for the two different classes, C0, C1. And then we started out just to have some missing values. We induced 20% missing values that are shown here. And then now we are going to use data imputation using mean for the corresponding variable. This is just a comparison of the original data versus the data having 20% missing values. You can see that couple of points are missing, especially in the this class shown in the green squares, which is the class 2, class 1. So now when we imputed using mean values, what happened was that again we have created a set of points which is leading to the creation of a new kind of class, as you can see here, because mean is another case, a special case of a default value also. So of course, the mean that has been filled here is the mean corresponding to that particular variable, but still, because it's a constant value, therefore it can also lead to the creation of a new class. So filling with mean is also not a good solution. Then other solutions we discussed was first median value. So median value is nothing but the centrally the middle value. And when we tried to impute the 20% missing data using the median value, again what we got was a new kind of a class in itself that you can see here, which is shown in the yellow stars. And this kind of distribution did not exist earlier because median is being used, but it's a constant value. And of course, the median has been taken on a per variable basis. That is, the median of the corresponding variable is used to fill in the missing values in that particular column. So this means that though median looked to be a good solution because it's a centrally located value for the variable, but it turned out that it is also not a good solution many of the times. Then the next probable solution was the mode value per variable. Now we use the mode. Mode would be the most frequent value in that particular column or variable. And we try to fill in the missing values with the mode value for that corresponding variable. And we again saw that some of the points were imputed somewhat correctly. So you can see the set of stars in this, the cluster 1. So you can see it in between the blue crosses, there are a set of points that have been filled. Similarly, in the cluster 2 shown in the green rectangles, you see a set of points which are showing the missing values filled there. So these are somewhat correct, but then it has led to the creation of a completely new cluster, which you are seeing at the value of somewhere between 8 to 10 on the x-axis and 20 on the y-axis. So here you see a new cluster, totally new cluster, and this new cluster did not exist, and therefore mode, though it's a most frequent value and it has been filled on a per variable basis, but that also turned out not to be a very good solution. So we tried mean, median, mode. All three were not good in this case. So now we are going to use another option in which we are going to use the mean for the variable, but the mean has been calculated by segregating all the samples on the class basis. That is, if we are having 50 points, we'll first divide them into two groups. All those belonging to class C0 are placed together and C1 are placed together. Then in the class C0, we are going to see how many missing values are there in the corresponding variable. And from the rest of the values, we'll calculate the mean and use this mean to fill in the missing value for that particular variable. So you can see here, in this particular case, since the mean was calculated for all the samples containing the data, that values for that particular variable, and it has been done on a class-wise basis. So the imputed values are very much close to the original set of values. So this method seems to be a much better option than all of the rest of the values. Then we also tried to fill with the most probable value. And there was a lot of discussion of, can we use only mode to fill in the most probable value? No, there can be a lot of ways to fill in most probable values. Mode is one of them. And I think there were suggestions of using k-nearest neighbor and all that. Yes, all that can also be done if that's possible. And so we now use the mode per class. So once again, we divided the samples into two groups based on class C0 and C1. And then we took the class C0, and out of that, we took one particular variable, saw what are the missing values, then found out the mode for that particular variable in that class and used the mode value to impute the missing values in that variable. Similarly, in the other variable also in the respective class, we looked at the missing values and then we used them to impute. And like that, we got quite a good distribution. Good distribution means distribution quite close to the original distribution. So these were all the methods, and this is the summary of what we discussed. So we were at this point yesterday. Now I'll start with the new portion, but before that, any quick questions anyone has before I start?
Ma'am, if the data is regression data, how can we impute the value?
The data is regression data. What do you mean by that?
Ma'am, here that we have taken the class, right? So we are separating out in the class like C1 and C2, and then we are imputing the value. Suppose if there are no any classes, we have a continuous data, and we have up 1 year of data or 6 months of data, and we have to impute the value. There are multiple input features, and which are impacting one parameter is impacting other parameter, and in that case, if we have to go with this, can we go with a mode or I mean in that case?
The example that you gave, we are having a data that is having some continuous valued variables. Those variables may be dependent on time or on each other. So this kind of data is much simpler to fill because there are dependencies in the data. So we can use the previous values to predict or forecast the next value. The forecasting can be done by a lot of methods. Regression is the most simplest form of it. So then we can find out the value and impute the value. So because in all these cases that I've discussed, the variables were all independent, and therefore we could not use the concept that I'm discussing, because in the example you gave, as you said that, for example, we have some data that is coming in at different samples of time, and the previous samples govern what will be the value of the next sample. So it's much easier to calculate by different forecasting methods and then impute. But mean, mode, and median and all are not good in that case, because data may be measured over time or data may be varying over certain parameters. So these may not serve the purpose at that point in time. Is it okay?
Yeah, got it, ma'am. Thank you.
Ma'am, Vikas here. Very good morning. One
Good
question I
morning.
have.
Yeah.
Ma'am, you spoke about multiple scenarios yesterday. So all these scenarios, so you have only two classes, C0 and C1. And when you have plotted the data, it is x-axis and y-axis. So in case of real data set, so these scenarios will remain same. So the solution that you have given for missing value, it will be only applicable for C0, C1, x-axis and y-axis, or it can be multi-dimension data.
No, it is applicable to any scenario. For the sake of simplicity, so that I can show a 2D plot, I have taken only two variables, okay, and only two class values. However, if you have a multi-class problem and you have multiple variables, then also the same thing will hold. Only thing, if you want to visualize, we'll have to do something more on the data, which I will show how you will visualize. I think there was a question related to this yesterday also. So I will be showing, if you have multiple variables, how to do plots.
Okay, thank you.
Hi, ma'am. Vivek here. Ma'am, can you go back to the previous slide, ma'am?
Yeah. Yes, this
Yeah.
one?
Yeah, please. So you are saying that we have two different clusters here, and we are taking mean of each cluster individually, like group by mean for each group, right? Say, suppose my mean is coming like say 3, my mean is coming as 3, my median is coming as some 3.2 or something, and my mode is again some 3.5. So suppose if my mean, median, and mode are coming at the same place, so how will I decide which one will help me in my modeling or whatever?
Yeah. So that's the reason why I showed all these graphs. I took all the same data and calculated, see, this mean, median, and mode and all that. So you can see here, you look at this mean value, right? So this mean is coming out to be very similar to the mode, as you can see here, right?
Correct.
There's very less difference. Now, how do we decide which one to use? So I will discuss this in the session where we do clustering or something. So
Okay.
basically, what we try to do is we try to find out the error in the data. So the values that we fill, and what were the original values versus what we fill. So there'll be a differences between the two. And we
Yes.
try to look at that difference and see which method minimizes that error. So we will choose that one.
Yeah. Thanks, ma'am.
Okay. So Ashwin, do you have something?
Yes, ma'am. My doubt is here that just one clarity that I required is that class is just one attribute basis which we are segregating the whole data, right?
So in this case, class is just additional information. The variables here are X and Y. Those are the two variables on the basis of which I am plotting these points. See, on this axis, we have one variable. This is another variable.
X and Y are variables fine, but for each X and Y, we have one class attribute which is 0 or 1, correct?
Yeah, that's correct.
Okay, thank you.
Yeah. So this class information is just an extra information. You can do the same thing, at least in this case, uh, even by group information. Let's say you don't have the class information, you still want to find out the mode. Then you'll have to cluster the points and do extra things. So I just, gave the example that you have the class, and using the class, you can do the mode. Okay, so
we have some operation that helps us find which attribute to group on, or will that have to be a given thing?
yes, you'll have to find, if you have to create the groups, then you will need to know which particular attribute to do the grouping on. Or actually, generally speaking, if you have multiple attributes or multiple variables and you are forming clusters overall on the entire data, you'll have to consider all of them together.
Got it.
Okay. I think now we can start with today's portion. So this is a summary of what we already discussed. So let's go to the next part. So now, so far we were talking about filling of missing values. So we covered at length imputing missing values. Now I'm going to talk about handling noisy data, right? Because again, we discussed that if we are having noise in the data, then also it's going to create a lot of problem for us. So there are a lot of different methods based on the type of data. I am going to talk about numeric data here, and hence the methods are primarily on numeric data, though conceptually on the other types of data, these may still hold. We'll discuss as we go to different data types eventually. So now, the first and the most intuitive way of handling noisy data is to perform binning. Okay, what is binning? Let's assume we are having some, I'm giving you a simple example from, objects that we see around us. So let's say we have a bag full of fruits, right? And these fruits may be of different kinds. We may be having some apples, bananas, guava, and something, grapes, and all that. So let's say that we are having some 4 kinds of fruits. We asked someone or we actually purchased some 4 kinds of fruits. Unfortunately, all of them were delivered to us mixed in a bag. Okay. And these 4 kinds of fruit, let's say, were apple, orange, banana, and grapes. Now, I want to segregate all these groups, so that I can easily identify what are the, I can put together, I can identify the fruits of a particular variety. So in that case, let's assume that now I've got 4 bins or 4 buckets with me. And what I can do is that as I pick the fruit, I can keep on putting the fruits in the corresponding bucket. So there's a bucket for banana, there's a bucket for apple, and so on and so forth. And now comes in so most of the fruits will get accommodated in one of these 4 buckets because we had wanted to purchase these 4 kinds only. But now it turned out that in this so many fruits, there was an extra kind of a fruit. Probably it got mixed by chance or for whatever reason. So in addition to these 4 fruits like apple, banana, and orange and grapes, there was a guava also. So then this guava is not going to be accommodated in any of the 4 buckets that we had decided to keep these 4 standard variety that we wanted. So then what will happen? This guava will actually get removed from the lot of the fruits just because we formed bins out of the, or groups out of the different varieties of fruits that were mixed together. And in this process, something which did not belong to any of the groups got eliminated. So this example I gave is very similar to binning that we do here. In binning, what we do is we sort the data and then partition them into groups or bins. You can think of bins as buckets of data, or you can think of bins as groups. And then using some particular notion, we are going to perform some operation on the bins such that the noise gets removed. Okay. Then another method of removing noise is that you form the groups using clustering process. Any point that did not get accommodated in any group will be removed as noise. Then regression is also a standard method wherein you fit a particular linear or non-linear curve or line or model onto the set of points, and those points that do not fit on the curve are removed as noise. Okay. So I will now discuss binning in more detail, but before that, I hope binning is clear to everyone. Any questions, anyone, on what is binning? Okay, Meghna.
Ma'am, when we say noisy data, right, the data could be like a fabric limit or it could be missing, right? So when we talk about sorting the data, and if some data points are missing, then how that gets added or sequentialized into that sorted values?
So your voice is not coming out very clear, but what I could understand is that when we are talking about noise, probably we might be having missing values as well. Is that your question?
Right. And if the values are missing and when we sort that out, then how does it fit along in the complete range of data?
Yeah. So let's say if you are having missing values plus noise, so what you will be required to do is if handling of noise requires sorting of the data, you will have to first impute the missing values, then only you should sort. Obviously, you cannot sort on missing values. Okay. So the order in which you treat noise or you treat missing value may not be so much fixed, but if both of them exist and we are using a sorting, we are using some form of sorting on the data values, then we'll have to first fill in the values and then sort it and then prune out the noise. Is that okay?
Okay, ma'am. Thank you.
Hello, ma'am. Am I audible?
Yeah. Yes, you are.
Ma'am, in the earlier example, we used bins to sort fruits, right? And you mentioned the guava being an additional thing. So, like, can we have guava in a separate bin and also consider it as a bin?
Yeah, so in the example I gave about the fruits, I said I was interested in 4 varieties of fruits, which were apple, banana, grapes, and something I said, oranges.
Yeah, that's
right?
okay. That's
So now this 5th kind of fruit I was not interested in, so it was noise for me. But
okay.
if someone is interested in our 5th variety, then it is not noise.
Yeah.
Okay, noise is something which is unrequired.
Okay.
Mhm.
Good. Thank you.
Yeah. Okay, Ashwin, good question. Yeah.
That I wanted. Can you define what you consider noise?
Yeah. So noise can be defined as some values or some part of the data which is very different from the rest of the data, or it is, not required. I'll give you a couple of examples. For example, let's say if there is a voice recording, and in the recording you are recording some song or music, and there were people chatting in the room, and there was some, some whispers or some noise in the back. You know, there was some people talking, and when the recording was done, along with the music, that thing also came. So in this particular case, because our focus was on recording the song, anything other than that was noise for us, including those chats. If we talk only about the chatting of the people, then it's okay to have chat recorded. But because our focus was on song, so anything other than song is irrelevant for us, so it is noise. So anything that is irrelevant for us or that is not following the pattern of the data will be noise. For example, let's say if you are having readings of the accelerometer, right? That accelerometer could be on the car or on a cell phone or whatever. And the normal way the car is driven, uh, uh, so you will see certain values in it. Now, if there is some kind of obstacle or something comes in between, then that value will change suddenly. Now, if we use that data for analysis, then and we want to consider what is the normal, pattern in the normal values, then something which is very different is considered as noise. So this is how noise is considered. Noise has the same meaning as the English word noise. Something which is useless, it's irrelevant, we consider as noise. Okay. So I think there is one question by Shashank, that how do we differentiate between binning and clustering? Binning looks similar to clustering. Okay. So actually, I'll discuss this as we go along. However, in bins, the bin boundaries are static and defined. In clusters, we do not define any cluster boundaries. We arrive at the clusters or the groupings, right, at the end of the process. So binning can be taken as a, clustering can be taken as a form of binning, but it is a special form of binning where there are no static bins, there are dynamic bins, because clusters are dynamic in nature. So that is the difference. Okay.
Thank you.
So now let's go to different forms of binning. Now the first form that I'm going to discuss is equi-width binning. So Gunjan, I'll take your question after I would have explained some part now. So in equi-distance or equi-width binning or partitioning, what we do is that, let's say we have a set of values or we have some points in the data. So we are going to look at the range of the values. So we'll have the lowest and the highest value. With the help of the lowest and the highest value, we'll get the full range. Range would be, let's say if B is the highest value, A is the lowest value, B minus A would be the range of the values. Now we are going to divide this range into partitions or sets, smaller sets of equal size. So let's say if I want to form n bins, then I'll divide B minus A by n. It's like this. You just imagine you have a rectangle. Okay. The one end of the rectangle represents your lowest value, and the other corner represents the highest value. And I want to divide this rectangle into width strips. Then what will I do? I will take the lowest highest value, then I'll find, which will help me to find out the length of the edge of the rectangle. And then I have to decide the total number of strips into which I want to cut the rectangle, and divide the total length by the number of strips. And then I'll get the length of each strip, and I'll cut it out into those strips. So equi-width partitioning is exactly similar to something like this. We divide the given set of range of values into some number of bins or partitions. They mean the same thing. And then based on that, we will group the data. Okay, so I'll show you an example. So let's have this example data. I haven't shown all the points. Okay, some sample points are only shown here. So this data is about people, and there are only 2 variables. I have not included all the variables just for the sake of clarity. So what we have are ages of the people who are represented by these rows. And there are 50 such people because we are having 50 rows in the data. And the one variable is the age, and the other variable or attribute is the medical expenses for that particular person with the corresponding age as shown in the age attribute or variable. Now, what we are going to do is we want to use equi-width binning to actually bin this data. So, and let's say we decided to form 5 bins. We could have any number of bins. Let's say we wanted to have 5 bins because we are having the minimum age as 20 and maximum age as 70. So we could have bins of 10 years if we are binning on age. So then our bin 0, so our bins are bin 0, 1, 2, 3 and 4. And the ages for each of the bins is 20 to 30, 30 to 40, like that up to 70. Okay. So now what are we going to do? We are going to replace the age with the bin ID. So let's say anything having, and the data has been sorted. That's why what you are seeing here is the attribute age has been sorted in the increasing order. So now what we are going to do, any age between 20 and 30 will be identified by bin 0. Therefore, the age is actually, you can think of it as being replaced by the value 0, which is nothing but the bin ID. And any age between 20 to 30 will be represented in this bin. Now, when we have ages greater than 30, we'll start out making the second bin. Here in this case, we have values starting with 32. So this comes into bin 1 and so on and so forth. So there are actually 50 values. So for sake of space, I haven't shown all of them here. So like that, we are going to bin the entire data. Okay. And then use the bin information in future. And any particular data point, which is very different from any of these bins, will not get accommodated in any of the bins. Okay. So I could see some hands raising. Any questions?
Yes, ma'am. Just you were mentioning about dynamic and static binning. I missed out that part. Just for the question.
Okay. So static bins are something like what you are seeing here. I have a lower value and a higher value predefined for the bin, and that's it. So this bin is now fixed. Similarly, bin 1, 2, 3, 4, all these bins are fixed. Once they are created in a particular way, we cannot change. However, in the process of clustering, based on the characteristics of the data, if the data changes or new data comes in, the clusters could be changed. In this particular case, if we have more points after 50 rows, we have more points coming in, the bin boundaries will still continue to remain the same. So these are kind of static bins. Okay. Whereas the cluster could change because we can still make new clusters. And if there are different properties, I mean the data is changing its nature, then also the clusters could change.
Okay, means clustering is also a binning, but that's a dynamic binning and this is static binning.
Exactly. Yes.
Thank you, ma'am.
Yeah. Okay, who's next, please?
So, madam, in the data we see the year 30, or for that matter, the extreme end of the is common across the bins. So, how do we identify whether it should be part of bin 0 or bin 1? For instance, bin 0 says 20 to 30, and bin 1 says 30 to 40. It should have been an exclusive value, right?
You are correct. So actually, I haven't included the exclusion or the inner and the outer properties. You can assume that if I'm writing 20 to 30, 30 inclusive is here, and bin 1 would have
Okay.
anything greater than 30.
30. Okay.
So
Makes sense.
yeah.
Thank you.
Okay. Khushbu, what did you want to ask?
And I wanted to ask that here we can see that the range is 50. Okay, so we have divided it by 5 because we need 5 bins. But what if the range is like 101? Then it cannot be divided. It is a prime number, so it cannot be divided by anything. So the bins, then how would we divide that?
So we are not interested in having the division of the number. Let's say if we are having a value 101 and we want to divide it into 5 bins or 6 bins or whatever. So we'll have to just keep on dividing. We have to decide a particular range of values to include in the bins. So no matter, even if it is an odd number, even a prime number or whatever, we decide the range or the range of values to be included per bin. So let's say if we have a value like 111 and we still want to form 5 bins, then each bin probably you have to divide 111 by 5 and see what you get, right? So you get 22 point something. So you take 22 as the bin width, or you could take 23 also as the bin width, and then go on forming the bins. So it doesn't matter what the value is actually.
Okay.
Yes, Lokesh?
Ma'am, one quick question, like how do we decide the boundaries? Like say
Yeah.
22. So how do
So
we
yeah, so I got it. How we find out which boundary should we use? So it purely depends on what we want to do with the data. We could actually, let's say if it is business data, then logical groups would be known, isn't it? Like for example, suppose I want to find out some weekly patterns from the data, and the data is having it is some variable measured on per day, let's say sales per day. I want to know what is the weekly sales, then I'll logically divide it into groups of 7 days. So many of the times we have some background knowledge to decide on the number of bins. However, if you don't have any information, then what we can do is iterate on the total number of bins, and then after binning, utilize the data to do whatever we want to do and see which particular bin value is giving us the best performance, and then we can choose that value.
okay. Got it, ma'am. Yeah, thank you.
Okay. Okay, anyone else before we go to the next part? Okay. Now, so here I've just shown the bins plotted. So these are the bin IDs on the x-axis, and what you are seeing are the medical expenses on the y-axis, because we had bin the age, and the age is now represented by the bin ID. So you are seeing all the points belonging to each bin on that particular bin ID. So you'll have some set of points belonging to bin 0. They'll all come on the same vertical line like that, 1, 2, 3, 4, 5. So now the bins have been formed, and all the persons have been put in the corresponding bin, which is done on the age. So any comments on this form of binning? That is the equiwidth or the equidistant distance binning. Anyone, any comments?
I think we can make the classes based on this, like there is no grouping or maybe clustering.
Okay, so while we are doing the binning, the purpose is not to form any clusters or not to form any classes. This has been done with some other reason. There could be multiple reasons for forming bins. Right now, we are discussing removing noise from the data. So anything that gets accommodated inside the bin is normal data. Anything that gets excluded is noise point. So we are right now concerned with denoising the data. Okay. Okay. We can. You can start asking quickly.
Ma'am, did
Whatever
we
of it.
consider null values here, missing values?
No, missing values. If you are having missing values plus noise in the data, you need to first read the missing values and then do denoising, because you cannot have both of them together.
So answering the null values in the sense like whatever we've discussed earlier.
Yes.
Okay, sure. Thank you.
Ma'am, one question. Right now, we're binning only on one attribute. Is there a possibility of binning on two attributes or more?
Yeah, definitely. These bins are 2D bins. You could have ND bins also. In such cases, you will have to have, you can think of, cutting out a cuboid into smaller cuboids. That would be 3D binning. If you have, yeah, so you can do that.
We start with one attribute and then add on more attributes to that binning, right?
So you assume, let's say if you have a 3-dimensional data or a 3-variable data, you visualize that the data space is not 2D, it's a 3D, it's a cuboid. Now you have to cut the cuboid using the range of values. So in this case, we have cut on the basis of age only. If you are having 3 dimensions, you'll have to cut on 2 to get rectangles on the third one, right?
Understood.
Yeah. Okay, anyone else?
Yes. And visualizing this graph, can we identify the outliers here? And I'm not like how would we consider what are the noisy data here?
Yeah. So what you are seeing here are just the bins. I only wanted to show you how to form the bins. Now, let's say that if there was a noise point, it will not get accommodated in any of the bins. Let's say our normal range of values of ages of people is 20 to 70. Let's assume we are having these set as the normal set. Now, if you have some person having, age of 90, then that will be considered outlier, and that point will not get accommodated any of these 5 bins. Similarly, if there's a kid of age 2, then for this particular data set, that particular point would be considered a noise point, because we are not interested in that age group. We are interested in the age group of 20 to 70 only. So anything outside that will be noise for us. So here you are not seeing the noise points. I'm only showing you how to form the bins. Once you understand how to form the bins, then anything that doesn't become part of any bin is removed as noise. Okay.
Okay, ma'am. Thank you.
Okay. So now, so I was asking you any specific observations on this form of binning. So the observation is here, when we are using binning, that is equivalent binning, then we can see that in each of the bins, we are almost having some similar number of points, right? So maybe approximately 10 or 10 points or so per bin we are getting. So the bins are all populated with almost equal number of points. Now let's consider another example. In this example, we have 52 points, and in this data, the measured attributes or the attributes shown here, variables are also called attributes. So that's a common way. So if I say attributes, you take it as a variable. So we are having an attribute screen time, another one sleep duration, and then we are binning on the basis of screen ranges, screen time ranges. Okay. So now these are the variables we are going to use binning on the screen time, and we are having 52 points, and we are going to form, let's say we assume we know that we need to form 6 bins. Fine. Now since we are using equivalent binning, so we'll have to look at the range of the values, and assuming the range of the values goes from 1.4 to 7.5 hours in the screen time, and we are forming 6 bins, then accordingly we are going to divide these range of values as you are seeing here. Okay. So one thing to note is I have specifically taken this example because here all the bins are of having width 1. However, the last one is having a larger width. So it's possible, let's say I know that I have to form 5 bins only or 6 bins only. Then initially we'll have equivalent bins, and the last bin may have higher, may accommodate rest of the points, or it may have points from 6 to 7 only, and anything other than that would get accommodated as noise. So if we are knowing that the value up to 7.5 is a normal value, then all the rest of the values are accommodated in the last bin. But if we assume that up to 7 only is normal, then anything beyond 7 would be considered as noise and it won't be accommodated in any of the bins. So now, as I said that there are 52 points, only a sample screenshot is shown here, and the bins have been found. And of course, I'll mention that though I've written 1 to 2, the bin 0 would have all values 1 to 2, and bin 1 would have anything greater than 2 and up to 3 and like that. Okay, so it holds for all of them. So I should have written greater than 2 here anyhow. Now, I'm going to perform the binning as mentioned here. And then this is the plot of the bins. So you can see here that we are having 6 bins as we discussed, bin 0, 1, 2, 3, 4, and 5. And all the values have been accommodated, assuming values up to 7.5 are all normal values, and so on and so forth. Now, having done this binning, that is equivalent binning on this data, are there any comments on this graph?
Most of the data got accumulated into 4 and 5th bin. So, do you think that the binning duration should be more, like instead of having 5 bin, we should have more bins into that because the data is more accumulated into only 2 bins?
Okay.
Also, I think bin 1 and bin 2, similarly bin 4, bin 5, they have the ranges are overlapping in a way, I think.
But is that a problem? I mean, is that a problem if it is more in, we just want to check the valid data?
Okay. So let me start out with a few things. First of all, it's correct that most of the data is actually binned in bin 4 and bin 5, right? And rest of the few points are only there in the rest of the bins. Remember, we started out with the idea of binning. And what is the idea of binning? We are going to segregate the data into these bins, buckets, or groups, whatever you want to call it, right? That was the objective. Now, when we are doing equivalent binning here, what is happening is all the points are actually getting accommodated mostly in 2 bins only. Then the whole idea of doing binning is getting defied. There could also be a case where all the points, come in 1 bin only. Can you think of any such scenario where all the points can get accommodated in 1 bin only? You can think of some other variables or some other data. Can there be any such case?
In categorical data, it can be there, if all are males or like that.
Okay.
And then in highly skewed data also, it could be there.
Okay.
If we have a wider bin range, per bin range, that could accommodate in a single bin.
No, I'm talking about not a wider range. I'm saying that whatever bins we have chosen, is there a possibility or could there be an example of numeric data where all the values get populated in 1 bin only? Could there be such cases? Okay, Rajat, what do you want to say?
Yeah, ma'am. Example of this can be the speed of vehicles on a highway which has a speed limit of 80. Now, if we do the binning from 1 to 100, all the speed limits will fall in the bucket of 80 to 100.
Yeah, correct. That's true. If there are vehicles, let's say all of them moving in one particular lane, one after the other, then they'll probably be having similar speeds. Of course, in India, if you go on a highway or expressway, probably that may not be the case. You'll find some very slow bullock cart kind of vehicles moving around, and there'll be some very fast moving vehicles also. Anyhow, okay, I think Subham, you had something to say?
Yeah, ma'am. So what I was thinking was, since this segregation is mostly on the right side, so instead of, equally, dividing the classes, can we have something like a frequency kind of thing? Like we can have like four, like the range we can modify a bit because we have static ranges now. So instead of the static thing, we can have more on frequency kind of thing, like that I was thinking.
Okay. Okay, we
Ma'am,
will just come
why
to
are we doing binning? Because we just want to filter out the wrong reports. Why are we when talking in terms of dividing the data in smaller chunks? Are we trying to filter them by little bit at a time? What is the idea here? I thought it is
Yeah,
about
yeah. So the idea is to remove noise only. That's why I'm discussing how to form the bins correctly. So let's say if you want to remove noise and you formed bins in such a way that all the data got accommodated in one bin only, then how will you remove the noise? You won't be able to remove the noise, right? That's why how to form the bins is of importance, and that is why we are discussing it here, Ashish. Okay.
Ma'am, in medical data, say if we are monitoring, blood glucose or fever or something, so there, the range would be very short. So in that case, it can fall into one or two bins.
Okay. That is one case. If in medical data, if all the patients are behaving very similarly,
Yes.
then they might fall in the same group. Okay, I think I'll quickly
Classroom
take, yeah, yes,
fifth class. Mostly everybody's age will be into one bin because most of them are of similar ages.
exactly. So this is a very typical example that let's say in a school, there's some, class or standard one students, all of them would be more or less of the same age. Now, if you want to segregate the students on the basis of, on some basis and you use age, then in that case, all of them will fall in one bin only. So you are actually not doing any binning. Okay, I'll quickly take these. I can see three hands and then proceed. Shashikant, followed by Meghna and Varun.
Hello, ma'am. So, regarding the accommodating all the points in single bin, in case of multi-attribute data, if we are binning on a column which is wholly depend on other attribute, like say there is an attribute A which has only values 0 or 1, and we are binning on attribute B, where most of the data or probably all of the data is dependent on a column A, let's say 0. So then that's the case where all the points will segregate to one bin only.
Yeah, that's correct. If you are having already some class labels, say 1 or 2, and you do it on that only, then all of them might fall in 1 or 2 bins. That's correct. Okay. Yes, Meghna?
Ma'am, I was thinking like, for example, in the last two bins where we are seeing the concentrations are more, why can't we say like the data which is appearing in say bin 0 to 3 could be outliers, right? For example, seismic data. Across the observation, the data will be very similar, but certain spikes result in are called as outlier, but could be an earthquake or something. So maybe isn't it a way like we consider bin 0 to bin 3 as outliers, remove them, and then do a rebinning on say fourth and fifth? Is that, can we say that and do that?
Yeah, so Meghna, what you're saying is correct. Suppose we know that the range of values that are there in bin 4 and 5 are the normal range of values we are expecting. So anything out of that could be treated as noise. So let's say that bin 4 and 5 are having, we already know the fact that the range of values in these bins are the ones that should be expected. Then the others could be treated as noise and removed, and then the rest of the points could be binned. So that can be a case. However, here in this example, what I'm assuming is that all the values right from the 0th bin up to the 6th bin, I mean the group bin number 5, all of them are legitimate values. Okay. If in the scenario that you pointed out, if we were knowing that bin 4 and 5 ranges of values are only the legitimate range, then it could be the case that the rest of the bins are containing noise. So our analysis is on the complete range presently. Okay. Okay, I think no more questions, so I'll just proceed. So the comment that I, of course, wanted to make and already pointed out by many of you, that only 2 bins are populated and rest of them are empty. We want to make bins out of the data. Bins should be logical bins. You cannot just make bins for the sake of making them. Here it appears that the bins have been made using equi-width binning idea, but they are just kind of pseudo bins because bins are made, but they don't contain anything, right? If bins are made, then they should be containing values, isn't it? Otherwise, we should just have 2 bins only. We shouldn't be having these 6 bins out there. So if we are making bins, then we need to ensure that all bins have values, right? So then this is kind of pseudo binning with 2 logical bins and the rest of them just theoretical bins. So then what do we do? So I think I've just given the number of points here, like 2 points, 2.11, and the rest of them 22 and 23 going in bin 4 and 5 respectively. So then we actually have to do something more. We already discussed all this, so I'm going to skip this. So we have another form, I think it was pointed out already, that why not have frequency-based binning. So in certain cases where if we do equi-width or equidistance binning and all the points fall in one particular bin only, then that means that that was not the correct way of doing the binning and we need to use some other form. So equi-frequency binning is also another popular method where we are expecting some particular variable to have similar values, then we can use this kind of binning. So I'll give you an example of equi-depth of equi-frequency binning, meaning the same thing. So here also we divide the range of values into n intervals, but our each bin must be having exactly or more or less the same number of samples going into it, so that it doesn't happen that some bins are empty and some are overly full. So let's look at this particular form of binning. Here I have formed the bins based on the count of the values. Okay, so now the bins here, the bin information you can see here, every 10 points are grouped in one bin. So here, if we count the first 10 points, you can see here, they are all accommodated in one bin, which is bin 0. Similarly, the next 10 would get accommodated in the next bin, which will be bin 1, and so on and so forth. So like that, bins have been formed. Therefore, the range of values are not equal here. The number of points are almost equal, but not the range. The range are just the ranges of these 10 values. It could be anything. That range could be anything. Now, if we make a graph, here we are having the bin IDs and here we are having the range of values. You can see here, and the y-axis has the sleep duration, and on the x-axis we have the frequency. So in a way, we are looking at binning the data on the basis of how many people have the same kind of sleep duration, right? And we have found out that certain, around 10 people have the sleep duration in the range of whatever number of hours that is mentioned here, like that. So it may be, this particular case. And now you can see that almost all the bins are having uniform number of points in it and none of the bins are empty. So in certain cases, equi-width binning may be a good option. In some other cases, equi-depth binning may be a good option. Okay, I can see some hands. Shikha followed by Utkarsh, please.
Yeah, ma'am, just one question. In the previous example and in this example, we saw that the last bin, no, the last bin has some extra numbers, obviously because we want to accommodate. So can we actually, is this a rule that only the last bin can have some outliers added, or can we add extra numbers in the first bin or in the middle bin also.
Okay. So again, it depends on how you are binning, but if we are binning on the basis of frequency, and let's say that in the end, just one or two, very few points are left, and you want to accommodate them. I mean, what I want to reiterate here is that we know that they are not noise points, they are lying in the normal range. Then just to accommodate them, we extended the bin. But that doesn't mean that you extend the bin so much that it becomes twice. You cannot make a count from 10 to 20. It's just some percent that you have increased just to accommodate. But it will be illogical to have, higher different frequency in between, because we are trying to divide on frequency. So at least the intermediate values all should be similar only. Otherwise, it looks a little illogical. Okay.
Yeah, got it. Thanks, ma'am.
Yeah. Okay, Utkarsh.
Yeah, hello, ma'am. Actually, I don't understand the logic of the equal depth. Equal width, I understood, but equal depth, what I think that the same value could be there in 2 or 3 buckets or 2 bins, 3 bins. So, like the screen time could be suppose 2.5. The 2.5 can exist in more than 1 bin.
How it will exist?
Can you go back to the
Yeah,
the data?
sure. Yes, yes.
Previous screen. You suppose you
Mhm.
see the 7.1 screen times
Okay.
7.1 is 0 here, and you suppose 7.2 something is down there. So
Yeah, yeah.
7.1 could be there in 2 bins.
Yeah,
Even
yeah.
7.1 could be 2 bins.
Yeah. So actually, you're right. Actually, again, data needs to be sorted again. Okay. I think I just took here I have not shown the sorted data. I just took a snapshot and put it here. So basically, you need to sort the data here also. Then only you count the frequencies. So that the problems that you are saying, that one particular value can fall in 2 bins, then we have problems in identifying which value goes in which bin, right?
Yes, ma'am.
So that will be solved. So assume that they are sorted. Okay.
Okay,
Thanks for the
thanks.
correction. I'll do it.
Which column we will do the sorting? Screen time?
Yeah.
One column sorting?
Yeah. It is one column sorting. Yeah, it is one column sorting only. So it is sleep duration. I can see it now. It's not screen time. It is actually sleep duration. Yeah. So, and sorry. And actually here also it's written sleep duration only. Yeah.
Yes.
I just looked at the first one. Yeah.
Like, so we have first for the sleep duration.
Sorry.
Depth binning, right?
Yeah, equi-depth binning. So these were the earlier bin IDs. Actually, okay, I think I missed telling you. Here, this is a mixed example I took, and that's why this sorting thing is there. So this data only, we had earlier done a width binning, and the earlier bin IDs are based on the equi-width binning. Now, what I did was, we did equi-frequency binning, and this was on the sleep duration. And so these are sorted, and these are the new bin IDs which we are using currently. These are the previous one, the earlier ones, which are based on the width. Is that what you were asking?
No. You answered my question. That was not the question, but yeah, you answered it previously. Thank you.
Okay, Ajit, you had some question.
Yeah, I have some question regarding the equi-frequency bin. We have sorted the sleep durations, and then we marked the 0, 0, 0, first 10 value 0, next 10 value 1. But in that case, if 2.8, 2.9, 2.9 is fall into 1, if that the first 0, 0, 0 has a first 10 value has suppose few set of data, that again continuing for the next set of data. Okay, in that case,
I got it. You are saying if there's a tie, right?
yeah.
So if there's a tie, it's a good example, I think, and it also somewhat, there was a question if we could have different number of counts in between. So this is exactly that case. So let's say that we had a tie like 2.8, 2.8, 2.8, all three having 2.8, and we wanted to take 10 frequency per bin. Then in that particular case, even though this was the 11th value, but it will still go in the first bin only. And it will have 11 values instead of 10 because there is a tie here. So this is a special case.
So in that case, we are checking rank only, yeah, dense rank kind of things.
Yeah, so actually, though we are having a frequency-based binning here, and we have decided some frequency already, but in case of tie of values, we'll have to reconsider that aspect of frequency as well, because the bins have to be unique and disjoint bins. Had we allowed overlapping bins, then it would be okay.
Okay, got it.
Ma'am, or else we
Thank
can
you.
add a small value to one of the values and we can move it to the next bin, right? Like very small value.
I couldn't get it. What is the small value that you are saying?
Like we can add a very infinitesimally small value when there are ties so that it moves into the next bucket.
Okay, see, what you are saying can be a solution. Again, I'll say as data scientists, you need, you already know you have got to do something. One thing could be that you just take the data as such because it is data belonging to some other owner. Only you are supposed to do the analysis and not touch the data, not change it. In such cases, you'll have to accommodate the data even if there's a tie by increasing the frequency in 1 or 2 bins or whatever. The second condition is that you can incrementally or to a very small extent change the data. In that case, what you are saying is correct, that you can just modify the values. Here actually, the values that I have taken are only up to 1 decimal. Initially, I had made the bins up to 3 or 4 decimal values that I rounded up actually. So if that is a possibility, then this could be avoided also, right? Okay, Mahesh followed by Prakhar.
Yes, ma'am. So as we started with it, okay, we already sorted this data with sleep duration, right? So as I could see the data is with different rows, okay. So 0.6 duration belongs to 7 screening time, right? So similarly, 2 belongs to 1.8, right? So, and if we again sort it by screen time, then I mean, there the coherence between the records will get affected, right? How could we again sort it by the screen time?
No, you can sort it. Only thing is that what you are seeing here is an ordering in the bin IDs based on the sleep duration. Now, suppose you sort them again by choosing all the, I mean, you'll have to choose the entire row. Then in that case, that ordering, I mean, you won't see consecutive values of the bin IDs like that. All you will see is some permuted combination, and that's all. If you want to do binning on sleep duration only, after doing the binning, and suppose now you want to sort on the screen time, you can still do it. Only thing is that the bin IDs will get permuted out in that thing. That's all. Yeah, until unless you want to do the binning on screen time, in that case, what you'll have to do is sort that entire data on the screen time and then do the binning accordingly. That binning will be different binning than this one.
Right. Okay.
Okay, Prakhar.
Yeah, ma'am, in one of your slides, like since we have set the frequency as 10, right? So in bin 4, we had 12. And since the main aim of this method is to remove the noise, right? Why aren't we like removing those two which aren't fitting into the bin 4 and instead of making it 12, and why can't we just keep it 10 and remove the two data, like which is not falling into the bin?
Which one
Maybe
you are
by
talking about?
maybe in one of your slide, ma'am, bin 4 you had like the 12. I think
This
it's the
one?
later one.
Later means earlier one?
Um,
Which are you talking about?
Last one.
Last
Bin
one, I
frequency.
think. Then
This one?
After that, yeah.
Yeah, this one, man. Yeah. So since like we have set the frequency as 10, right? And in fourth bin we have 12. So why aren't we like just removing these two extra count? And since the aim is to remove the noise from data, right? So can't this two fields be considered as noise and removed from the overall data set?
If we are having, let's say, a tie of values as we discussed, and some particular bin is having some 11 or 12 points, we cannot remove because we are breaking on the basis of the sleep duration, right? So we already have a continuous sleep duration going on. Now, if let's say in bin ID 1, let's say in this range of values from 22.9 to 3.7, instead of 10 people, there are 12 people falling in this range. Then can we treat that as noise? Because let's say there were 3 people having 3.6 as the sleep duration, right? So that cannot be noise. That's only a tie of values. So you cannot remove that as noise. The noise would be anybody, if we are doing a binning or sleep duration, anybody having a sleep duration, let's say of 12 hours, that could be a noise point if up to 10.2 is the normal range. Similarly, anyone, if we have someone having a sleep duration 0 hours, that's definitely a noise point because that's practically impossible for anyone to have a 0 sleep hour, right? So
yeah,
in between the range, we cannot remove as noise. Yes.
Okay, ma'am. Got it.
Okay, Ravi.
Ma'am, exactly what I understood is this equal depth bin helping us to categorize our samples and getting the durations based on the number of samples available here. How exactly we will utilize this data to eliminate noise? As we, if I understand it rightly, we have made the data more granular. However, we did not eliminate anything which we are looking at that as a noise.
Yeah. Okay. So as I told earlier, because we need to make bins to be able to remove noise. So what I'm showing you here is an example that does not contain noise. It's only showing the bins. Now I could have had some point probably. Let's say if there was another point which is having a value of 12 or 13, then it would get accommodated in any of these bins because we have made the bins definitely on the frequency count, right? But after making the bins which are made on frequencies, we also got some range of values associated with each of these. So anything which is having a range of, which is having a value which is very different from any of these bins, then it will not be part of any bin and it will be removed as noise. Why we have used counts here is because we wanted to have bins which are having values in it. But after using the counts, we have got cuts on the sleep durations, right? So these cuts are defining the values that will fit into all of these bins. So the first bin is based on the count, but the range of values that are the legitimate range will be 0.6 to 2.8. Now anything less than that, because this is the first bit, would be noise. Similarly, anything out of it beyond 10.2 would be noise. But I haven't shown the noise points here. I think I should have added. I thought that I'll explain to you how we form bins. And then you can use the bins to eliminate noise. That was the idea of showing this graph. Okay.
Understand rightly, not only the sample count, the duration of the range also we have given. It is not basically derived from the data. Is my understanding right?
No, this is derived from the data only. See, in this data, the binning is done on frequency. So we formed the bins of 10, 10 each. Having formed the bins of 10 each, if you go back here, I cut out these first 10 sleep durations. After doing so, I observe that, the range of values that this is having is from 0.6 up to 2.8. See, how I formed the group, I took the top 10 after sorting. At that time, I did not know what were the values. But after I'm done with, choosing the first 10 values in the sorted list, then I have a look at what is the duration and this defines the values in the bin. So now the values play a role. And these set of values only will be used to eliminate noise. Okay. Okay, Utkarsh, you raised a hand and.
Yeah, actually, ma'am, for this binning, I believe one should have a great experience on the domain of data. Otherwise, binning won't make any result to us.
Utkarsh, you are very correct. So, any senseful analysis of the data can only be done, whether it is binning or anything else, till and until we have some domain knowledge, right? Without that, we will be doing an analysis for the sake of doing it. See, let's say I don't have any idea about some data that is given to me. Then as a computer scientist or a data analyst, I'm going to do something out of it. Now, how meaningful that will be to a domain expert. There's a lot of noise actually.
Ajit
Yeah.
was having.
Okay. So, as a simple data analyst, we can only do analysis or we can do something with the data. But whether that analysis is going to be useful, that will be decided by the domain experts, or if the analyst along with the domain expert get together and that's the best possible combination, then only it will be useful. And that's why we are having this certification course, right? Because all of you are, most of you or many of you are working in some domains, but yet you want to do something with your data which you are not knowing right now. So once you learn this and you already have a domain expertise, then you can become a very nice, expert to play around with the data and to get some meaningful insights from the data. Okay, I can see two hands. Venkat followed now.
So, ma'am, when we are going to judge whether a data point is noise or not, that should not be part of the data used for creating the bins, right? Because if it is used in creating the bins, it will anyway be in one of the bins, because we
Yeah,
are
so
taking until the last point.
correct. So anything that gets normally accommodated in a bin will not be noise. That's the idea of doing the bin. Anything that doesn't get accommodated in the bin should be noise, which is not shown here, but it should be.
But we are formulating the bins based on all the points in our data, right? So if we have to say, if we have to decide whether something is noise, then we should be like, it's kind of the data which we didn't use in the formulation of the bin.
Correct. And that's why I told you, actually, I agree, I should have included some noise points also here. So what I'm showing you here is only how to form these bins. But noise points are not there. Probably next turn or so I'll include some noise points also. Or you can assume that there were more points. Let's say I have a point with a sleep duration of 15 hours. So then if that point was also there, then that would be a noise point for, in this data set. Or if there's, as I said, if there's a sleep duration 0, that would be noise, because obviously it won't be accommodated in these bins if we are assuming that these bins show the normal behavior of any person. Okay. So those noise points are actually, I didn't include any noise here. I only wanted to show you how to form the bins, which is what I'm showing you here. If you learn how to form the bins, then you can form them and eliminate noise. Okay, Meghna followed by Shashank and Lahari.
Ma'am, is there a mathematical way to determine the size of the bins?
Yeah, I already told, yes, you can do that. Let's say that you have no idea about what should be the bin characteristic, like size of the bin or whatever. Then you'll have to iterate. Let's say that there are 5 possibilities or 10 possibilities you think could be there. So then you go ahead, form the bins out of all those possibilities. And then after binning, use the bin data to do some further analysis and look at the goodness of that. Let's say once I bin the data, I use that data for doing some classification. And then after doing the classification, I see how good was my classifier model. So that particular number of bins will be chosen that gives the best performance. So like this, you can iterate upon the different combinations possible and then decide which one would be the best one by utilizing the bin information in your further analysis and then looking at the performance of that analysis. Okay.
Okay, so we have to iterate through this like noise removal. We implement the algorithm, we analyze the end result, and then again based on the analysis, we come back and then reiterate the entire step.
Exactly, exactly. That's correct. Okay. Shashank, followed by Lahiri.
Yeah, ma'am. Ma'am, I understood both the concept of equal depth and equal width, but I have one doubt. That outlier will only be existing in the bin 0 and bin 4, right? Now,
Sorry, outliers will be existing in bin 0 and bin 4, you are saying?
yes, right?
Okay.
In the either of the extremes of the bins, right? And in that case, we will be deciding with the value, a threshold value, that okay, if the sleep duration is less than 0.1, it is an outlier, and if the sleep duration is greater than 12, it will be an outlier. In the earlier case also, we are deciding a value, right? That okay, you have the years, if the maximum value of the year is 70, suppose 70 years, and the minimum is 10 years. So in both the approaches, we are deciding a threshold, and the bin is existing in the 0 or the higher extreme. How both are different? Because they both are same, right?
No, the way they are formed is different.
Yes, only so when we will be taking which approach, and in which use case it will be better to go with the equal depth or go with the equal width, because both are same in terms of the width, in terms of getting the threshold, and in terms of getting the outliers.
Yeah. So if you feel that you are, performing the binning on some particular variable and all the records are having similar values in that variable, then you cannot use it to do the binning, right? I ask you to form bins on age, but all the people are similar aged people. Then you cannot do binning on age. Then what will you do? How will you utilize age to do the binning? I said that you have to form bins anyway, and the bins have to be formed on age. But age is having same value, then we use frequency. That's how we decide out of these two methods which one to use. And there are many other ways also to do binning, which I will tell you shortly. Okay, but it depends which particular attribute is to be used for binning and what we want to do with the bins. Depending on that, we will decide what to do, I mean, how to form the bins. Okay. Is it okay, or anything else you want to ask?
Yeah, actually, our main aim is to remove the noise, right?
Correct.
So we are creating the bins. That is not necessary, right? Because we are already making a threshold that okay, lower than this and higher than that will be a outlier. So what is the point of creating a bin then?
See, the thing is that here in this particular case, let's say we took binning by frequency, right? Okay. So the ranges have come only after doing the bin. You didn't know them earlier, right? You didn't know them. Once you do a binning, you sort the data, do bins by frequency, then only you look at the range in that particular bin and okay, you say this is the first bin, this is the range of values, this is the next bin, like that you decide. Now you get, okay, anything less than that or greater than that would be an outlier.
Yeah, ma'am. So for data analysis purpose, I think binning will help us that, okay, this is the range, how the frequency and depth is there. But for removing the outlier, we are already segregating that it will be either in bin 0 or bin 4. It is not falling in any of the other bins, right?
You're right, Shashank, to some extent, but binning is very important because you will be using it very often in lot of other things. That's why also I'm covering it very much in detail. So binning shows how discretization is done. I will discuss discretization in the next class. And discretization is of lot of importance in data analytics. So, for example, if you have binary data means you're breaking the range into 2 values. I want to, break the range of values into 5 values, then how will I do it? So this is how you will do it. So this is also what I wanted to teach when I talked about binning. So I'll rediscuss it when I come to discretization. However, as of now, what you are saying is correct, that if we are only looking at the extremities, right, then we can use the lowest and the highest value also. However, it is also useful in other ways.
Got it.
Okay, I think one last question before I proceed. Yes, Lahari, what do you want to ask?
Thank you, ma'am. So my understanding of equi-depth is that same to equi-frequency, that we divide the data into the similar counts sections and irrespective of the range. So here, why didn't we divide it for 10 each, and the 2 points which we're missing will be the outliers?
So I discussed that earlier, that suppose we assume that anything greater than, let's say these 2 points were having values 10.1 and 10.2, and suppose we know that up to 10 is our legitimate range, then we can exclude them as noise also. Here I just showed that if there are few values that we think are in a legitimate range and we want to accommodate, and they are not changing the frequency very substantially, so they have got accommodated. But what you are saying can also be done based on the fact that if we know that sleep duration X is the stopping point for us, so anything beyond X will be excluded as noise.
Okay, thank you.
Okay. So I think we had a fairly good discussion about the different aspects, and definitely we are using binning for elimination of noise, but it's also possible. Binning is in other things, which we'll discuss as we go along. So then, so equi-frequency and equi-depth mean the same thing here. Both of them relate to the same thing. And we had these bins and we had these ranges, and we used the bins ID. Now, as I said, there can be so many ways to do binning. I showed you 2 of them in more details. So mostly whenever we are doing the binning, we'll have to first sort the data. Let's say we have some data of price of commodities in INR, and they are sorted out like this, and they comprise of some 12 values. So we could do binning based on the frequency or depth, which is the first one that you are seeing in the top one. So let's say each of the bin, because we are having 12 points, we wanted to accommodate 4 points. So we are having bin 1, 2, and 3, and they are accommodating these values. And this is the form of binning which we just discussed shortly. And then there could be also, okay, so this is binning by frequency. Now, there could be bins that eliminate noise because we are doing forming bins by means. So what does it mean? Let's say that, I have to divide some 4 points. I have to divide the data into equal values. Now, let's say I have these equi-depth bins, and these equi-depth bins I want to use to denoise. I want this data to be denoised. Let's say I assume that there are jitters in the data, and I want to do that. So what I will do, I will actually use bin means to replace all these points by the bin means only. So now the means of this would be 9. So all the values are replaced by 9, and all the jitter inside the bin is lost, and you just have one value inside the bin. Similarly, in bin 2, you replace it by the bin mean, bin 3 by the bin mean. So like this, you are actually removing the jitter in the data and just retaining a single value. So if you think about it, let's say that, I'll just use a pen. Let's say we have a set of points like this, and we have some points like this. We have a graph like this, So this bin means is actually going to do this. It's actually going to replace this set of values like this, like this. This is all we'll do. So you just take the average of these values and replace it. So this is what we are doing actually by when we do smoothing by bin means. If you do smoothing by bin boundaries, then you are replacing the initial or the final value based on the closeness of them. Okay. So here, what are you doing? You are actually, let's say the set of points are 4, 8, 9, 15. Having formed these bins, we are going to use these bins to do, denoising. So how do we do denoising? One way to do is that replace all the values with the closest bin boundary. So this is like 4, 4, 4 and then 50. And then you have like 21, 21 and then 25, 25 like that. So you are just left with the highest and lowest values and all others values intermediate are lost. For example, if you look at this bin, I mean these set of values, then your bin would be something like, having just either the minimum or the maximum value and nothing in between. And that will be your bin. So again, here, this is another way of smoothing the data by the bin boundaries. So having formed the bins, you can utilize the bins in so many ways. You can use the range of values to do denoising. You can use bin means to do the bin, the denoising. You can use the bin boundaries and so on and so forth. You can use any of this stuff to do denoising. So these are some of the ways, but this is not an exhaustive list. There can be so many other ways of forming the bins, and they could be, formed and utilized like. Okay, so this is what I wanted to show here. Then this is clustering. Now, I think there was a question also that won't bins be the same as the clusters? So at that time, I had said that bins are actually a form of, static clusters, right? You have defined how the bins are going to be formed, and that's it. Now, any point will get accommodated in those bins only. But if you are doing clustering and the number of points keep coming in, and they are very different, then what will happen is that we can also redo the clusters. So anything that doesn't get accommodated in the normal clusters is eliminated as noise, as you can see here. So this is how we do denoising using clustering. Then we can also use regression to do noise removal. Let's say we are having a set of points, we fit a linear line on it. It could be linear, non-linear, anything. In this example, I'm talking about a linear line. So any point that is lying on this particular plane or line is actually satisfying this condition of the equation and is not noise. But anything outside it would be considered as noise, and it will be eliminated. And this data of so many points will be actually replaced by this line only, and the rest of the points will be removed as jitter. So like this, regression is used for smoothing of the data. So then regression could be linear, non-linear. Linear regression looks at minimizing the error or the distance between the fitted line and the actual data points. And then based on minimization of that, we call them residuals. That is the difference between the actual values and those values that we obtain from the fitted line or the model are set. That difference is said to be the residual, and we want to minimize the residuals. And this is what we do when we try to fit some curve or line on the given data. It could be linear or non-linear. So here's an example again. You have so many points. The original set of points are shown. And then when we try to do some form of regression, let's say it's logarithmic or exponential, then we are fitting all these different curves on the given data, and any jitter is then removed, any other thing is removed. So is it okay so far? Any questions? Because then I'll begin with data transformation.
I could not understand the regression, so if you can just give me
regression.
Yeah, more example of regression.
Okay.
Same here, ma'am.
Okay. So now let's say that okay. Let me choose something. Okay. Now let's say that I have some set of points. Okay. So I have, let's say, some person who's walking in a field, and I want to find out the path of that person. Let's say, and in between the person also stopped at some points, but I want to find out the overall path followed by the person. Let's say this. There are some points that are marking the location where all he stopped. And this is a big field or a park where he was actually moving. Now, so let's say these are some of the locations where he stopped. And I want to look at the overall path followed by that person. So to find out the overall path, what will I have to do? One thing is that I connect all these points in that order, right? And then I get a path. So for example, I keep connecting these points, like like this, like this, like this, and so forth. So actually, though these show overall path, but a better way to express the path is unnecessarily, there's no need to keep all these, right? We can just keep the overall trajectory information. So the overall trajectory information would be something like this, isn't it? So this is the overall path followed by the person, this is the source, and this is the destination. And in between, these points actually are not of much relevance, because we only want to understand what is the overall pattern in the path. So any particular location that falls on this particular line is satisfying this condition and will be retained. But anything away, for example, this point, this is away from this line, right? So this is the error. So this is the estimated value. This value at this point is the estimated value. However, the actual value is this. So the error between these two, we say residual, okay? And we find out the error with respect to all the points and sum total it. And any line fitting the data is done in such a way that the error is minimized. Okay, so now what are we doing? We are removing all these points which are away from this line that we have fitted as noise points. Is it clear, Gunjan? So
Yes.
the
But this creating this line, we will learn in further stage, right?
Yeah, creating a model out of the data you will learn. However, this is the most basic form of it. This you learnt in your class 8th. Y is
Yes.
equal to mx plus c.
MX plus C, yeah.
Yeah.
Yes.
Okay. So anything which is not falling on this line is considered noise and is removed. This is what I want to say in regression.
Okay.
Okay. Any other questions? Okay,
I'm
we
not
know.
sure if we have already answered that. So will it always be a straight line, or it can be like parabolic or those kind of lines also?
Yeah, it can be anything. It could be linear, non-linear. Just for sake of simplicity, I've taken a linear function. That's all.
Got it. Thank you.
Ma'am, can go to the previous page where there is a something equidepth by boundary is mentioned.
Yeah. This one?
Yeah, the bin boundary, smoothing by bin boundaries. So
Mhm.
how we come to that, these values? Can you explain?
Yeah, so I told you that we are sorting first the data and we are forming bins by the depth. So we decided that 4 points will go in each bin. Now, we want to denoise these bins. We want to smooth out the values. This can be done in a lot of ways. One way was, instead of individual values which add jitter to the data, replaced by the bin means. Another is replace the individual values just by the bin boundaries. So whatever value is, it will be replaced by the boundary closer to it. Like 8 is more close to 4 rather than to 15. So it will be replaced with 4. 9 is more close to 4, it will be replaced to 4. And then the next value will be 15. So here you only retain the boundary information. You don't retain anything intermediate. And in this way, you are actually also smoothing out the values. See, let's say that if I have a range of values from 4 to 15, like you see here in the equi-depth bins, we have put 4 values. Now, if you look at the range, it is going from 4 to 15. So how many values would be there between 4 and 15? Actually, in the data, how many values are possible between 4 and 15?
Yeah,
It's
4.
going, no, it's
12
yeah.
or 100.
So here there are 4, but the possibility is infinite, isn't it? That you could have infinite values between 4 and 50.
Okay,
So
okay.
yeah, so if values keep coming in between, you'll have to keep on accommodating, right, in this range. So to reduce the complexity, we are replacing by bin average and just removing all other values as noise, or we are replacing by bin boundaries and removing all other ignoring all other values as just noise points, like that. We are
Okay.
just smoothing the data.
Yeah,
here.
sure. Thank you.
Okay. So, okay, Shubham, what did you want to ask?
Ma'am, just one quick question. So, can you just tell me a bit about how to have this intuition? Like, I'm not too much over smoothing the data, or like that smoothing. How much should I smooth it? I mean, see, smoothing by bin means it's like replacing every data. I mean, I can consider it as data loss also, but like I'm not over smoothing. So, how will I generate that intuition of it?
Yeah. So, of course, you cannot have any intuition. I mean, you may be having an intuition, but that intuition may be correct or wrong. So that's why I said that, let's say that, we are smoothing by bin means. And after smoothing, we will put that data to some use, right? For further analysis. Let's say we do clustering, we do classification, or we use it in some way. And if the performance of that particular model degrades, then it's not so good. Then whatever notion we use for smoothing out the data may not have been correct. So we'll have to actually use the data further to understand whether what we did in the past was indeed correct. Or the other option is you have some domain expert to guide you whether this is good or bad in the given data. So that is a good option, that if you have a certain kind of data, you have some financial data, and you have some person from the domain guiding you through how to to decide which one is the good option. So like that you decide.
Okay, so it's
Okay.
mostly about domain knowledge and what I'm doing. Fine, sure. Thanks, ma'am.
Yeah. Also, all these bins, once formed, they can be used for a variety of things. Like, for example, that I will discuss in future, that we can actually reduce the data also. So I'll come to it slightly later. Let me just take a little more before we wrap up for today. Okay. So we had talked about data cleaning only so far. And the next task was data transformation. So in data transformation, we actually change the data from one form to the other. But while we are changing the data, we have to remember that we should not change the data in such a way that the overall analysis gives different results, right? So the data transformation must be done in such a way that the overall distribution of the data is intact and the analysis still gives more or less the same result. And it doesn't generate some new insights, or something which was not existing comes up. That should not happen. So how do we transform the data, there are so many ways. One is data aggregation, another is data normalization, then attribute or feature construction, and so on and so forth. I'll talk about some of these as we go along. So data summarization is simply aggregating the data on some particular variable. For example, I have a unit of time as a measured variable in the data. So I could summarize the data on that particular variable. Say, for example, my data contains values measured over seconds of time. Then I could summarize it in minutes. I could summarize it in hours, in days, weeks, years, and so on and so forth, or on decades. So it depends. So when we try to, aggregate the data on some particular variable or some way, then it is part of aggregation. And once we have done aggregation, then we actually ignore the raw data. So we have transformed the data so it becomes more coarser. It was fine-grained earlier, it becomes coarse-grained now because it has become more generic and we have merged some of the values. So that is about data aggregation. Then normalization. So normalization is very often used, even if you are using a function, you might be seeing some normalization happening in by default in that particular Python function or whatever. There are types of normalizations. I will only discuss two types, min-max and z-score, which are quite popular, but you can look up for other forms of normalization as well. Let me start out with data transformation, in which I'm going to particularly discuss normalization. So the first form of normalization that I mentioned is min-max normalization, where we take a set of values to a new range. For example, the initial minimum value is given by min A and max A is the maximum value for any particular attribute A. Now we want to scale it to a new range. The new range would be new min A to new max A. So we can do that with the help of min-max normalization. I think this is a very common form of normalization. For example, that we have marks out of 50 and we want to find out the percentage. Then we'll scale the range of the marks from 0 to 50 to 0 to 100, like that. So this is like min-max normalization, choosing a new range of values and mapping the data on that new range. So if I talk about the value of 50 in a range of 50 or in a range of 100, so we have to map that value 50, let's say that, 50 on 50 means full marks. Accordingly, it will be mapped to, in a range of 100, it will be mapped to 100 out of 100, right? So that value will change accordingly. Then we have z-score normalization. This is often used especially in marking and deciding grades and all. So you have the value minus the mean. So we are actually offsetting removing the mean. So we are only looking at the fluctuations in the data and dividing it by the standard deviation. And then we find out how much variance in the data is. Like, for example, if a data point is, let's say 1.5 times less than the mean value, or it is more than 1.5 times, then these are exceptional values and we accommodate them accordingly in a very low or a very high grade if we are talking about marks. So I will show you examples to make it more clear. Let's say we have this data in which there are 20 values in X and in Y respectively. And we want to perform min-max and z-score normalization in each of these. So this is the initial graph. It shows the minimum value of X as 1 and maximum value of X as 20. And minimum value of Y is also 1 and maximum value of Y is 25. So these are the set of points that are given to us. And we want to perform some form of normalization, whether it's min-max normalization or z-score normalization. Let's say we want to do a min-max normalization and we want to bring the range of X variable, which was having values 1 to 20, to a new range of 5 to 25. And Y was having 1 to 25 and we want to bring it to 10 to 40. So then using that formula that I already showed you, you can map the values to the new range and obtain the new set of values. which you are seeing in this blue color. So this is the original set of values starting with 1, 1, 1, 1 for x and y, and the highest value is 20, 25. 20, 25. Now you are mapping it to the minimum range of 5 and maximum range of 25. So like this, you are actually mapping the values to a new range. So this is how you perform min-max normalization. And then this is z-score normalization. So in z-score normalization, what we try to do is, first of all, we subtract the mean. So when we subtract the mean value, we are actually just looking at the fluctuation or the variation part. And then what we do, divide it by the standard deviation. So you can see here the 0, 0 is lying in between here in the center. And we are looking at fluctuations on both the sides from beyond 0, 0 and less than 0, 0. So this blue plot actually shows the z-score normalized value for this yellow or the orange curve, right? So I have also drawn this independently. You can see that the center of the graph is at 0, 0, and then the values are normalized, z-score normalized, and they have been after normalization, we can see that the highest value is coming out to be around 1.5, 2, and the minimum value is around minus 1.5, minus 1.5, like that. So this is often used in marking. So anybody having such high marks would be given as the highest grade, and those having marks here around would be getting lowest grade, say F or something. This is how we decide which what should be the range of marks for the highest grade, lowest grade, and all that. And it is always done with respect to mean. For example, mean could be grade B. Anything at 0.5 times of the mean would be something, at 1.5 times of the mean will be something like that. So this is how we perform z-score normalization. Okay, Shubham, you have some question?
Ma'am, can you please show us with one practical example? I mean, that calculation, can you show us how you are getting back? Maybe in the min-max normalization.
Min-max normalization?
Can you show that calculation once, how we are doing
Okay.
this?
Yeah, you can do this. This pretty, just give me a second. I'll choose a pen and show you. So this is the formula. This is here is the formula. And let's say that.
Ma'am, here we have only one variable for min-max, right? How we are, taking care of x and y both here?
Yeah, you will do this for both of these. Just a second, just a second.
Okay, okay, sure.
So when you are doing a value, right, mapping this to a set of values, then what are you going to do? Your x from minimum value to other minimum value, right? Let's say the range is 1. This is the minimum of x and y. It's coming out a little, but anyway. X, this is, and the max range is
okay, ma'am, I think it's okay. I mean, I understand. Like we have to, okay, we have to calculate separately for x, separately for y, and then we have to plot.
Yeah.
Right. Okay. 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 Fine. It's okay. I got it.
Okay. The question.
Ma'am, is there any reference point where we can see this calculation happening, or we can refer that or try it by?
So actually, the calculations, as all of you can do it on these points. You can choose new
Ma'am,
range.
your voice is breaking.
Sorry to interrupt you, but yes.
Ma'am, can you show the calculation actually?
Okay.
Because I'm not getting, ma'am, one minimum and then new minimum. I'm not able to understand that.
Yeah, same.
Are you able to hear?
Yeah, now it's better.
Share that. Yeah. Okay. What did you know? You want to map it to some.
You need to understand the calculation, ma'am, because I am not getting that minimum A and then new minimum A, how to get these values and to calculate.
Okay. So see, this is the minimum X right now. This is the maximum X, right? So your max A would be difficult to write. This is 20 and this is 1, let's say. It's again min of 1.
Right.
Now, I have to map this range of values to 22. Let's say I want to map 5 to 25. Okay. So my new minimum value, my minimum value should be, and my new minimum value should be 25. This is what I want to do. So I'll substitute values here. So here max value T and min value 1. So difference of the range was 20 minus 15. Okay. And then the range of values will be 20 minus 5 is 20. I'm mapping the range of values of 9 to a range of 20. So value, let's say now the value like, okay, this 4, here this 4 means 4 out of 20. Now I want to put what the value of be
Ma'am,
out
your
of,
voice is breaking again.
I don't know what's happening.
Ma'am, maybe you can go off video. That will help the bandwidth to work properly.
Yeah,
Yeah,
maybe
just
better,
maybe you
but
can speak. Yeah.
I shouldn't be better now.
Yes, better.
Yes, ma'am. Better.
Yes, it is.
So what I'm is that earlier had a range of value 20 to 1, that's 18. To map it to 2 to 5.
It is still breaking.
I don't know what's happened. Let me do the meeting and rejoin. That's what I'll do. Yeah, hello. Is it better now? Are you all able to hear?
Yes, ma'am.
Okay. Okay, so I think I was here. Maximize this. So this z-score, min-max normalization is nothing but mapping the values to a range to a new range. For example, let's say that you go to US and you see, something that is priced at 4.99 USD. Now, you might think in mind, okay, in USD it's 4.99. How much in INR? Then what will you do? You will map the value, the range of values accordingly. Like 4.99 USD is like, you convert it and you take it in the range of rupees. So it is something similar to this, that you map the values to a new range. Or I say that I got a CGPA of, 7 on a scale of 8. So if I have to now convert it to a scale of 10, then what shall I do? How shall I find it out? 7 on 8, I got a 7 on a scale of 8 and I want to put it on the range of 10, then I can use this formula, right? Min will be 0, max would be 8. Now any current value is said to be new. I was doing that calculation actually. So let's say the minimum value in the current range is actually 1, right? Here I said maximum is 20. I'm not able to write nicely, but anyway. And then minimum value is 1. This is your original range. Now I want to bring it to a new range. Let's say the maximum value for the new range could be anything, say 40. Okay. And the minimum value could be anything, let's say 5. So I want to map the values of 1 to 20 to a new range of 5 to 40. So this normalization will help me. Now suppose the value 4 in the range of 1 to 20, how much would it be in the range of 40 to 5? So I'll put 4 here. Okay, 4 here, and then calculate the new value. So whatever I'll get will be equivalent to having 4 out of 20. In the range of 1 to 20, what will be 4? That will be same as this new value that you will get in the range of 5 to 40. This is what I'm going to calculate using min-max normalization. I did not include calculations with the thought that you can use these values, substitute and find out. That's why, but I have plotted them here if you wish to see. Just a second, let me just erase this. Otherwise, it will come on the graph. See, by doing all these calculations, actually, after doing all these calculations, what I have obtained, these are the original set of values. And after doing this, let's say I wanted to map to a new value in the range of 5, 10 and 25, 40, then these are the values. If you do the computations using that formula, you will get these values. Is it okay, or you still want me to calculate? Then I'll have to include the calculations.
Got it, ma'am.
Okay. Okay, any other questions, anyone? So these are very important normalizations, because many a times why this is very important is, let's say I've got, I want to report the sales over a product. I'm responsible for doing the sales. And one of, the unit is in India, one is in US, one is in, some other country, say Australia. And then how do I say which one is doing how good or bad? Then because in India it sells in INR, in US in USD, and like that. In Australia, Australian dollar. Then what will I need to do? I'll need to normalize them to the same range. Let's say I normalize all the sales value in currency, respective currency, to a range of 0 to 1, or whatever range I fancy, and then compare how much was the sales in India versus Australia versus US, and see where I'm performing good. So like that, normalization is of a lot of importance when we have different ranges of values and we want to compare them all together. Right. Now suppose I've got some 3 variables in my data, and one of these variables is having a range of values, let's say 0 to 1, the other is having 10 to 10,000, the other is having 1 to 100, right? Then it won't be very easy actually to compare all of them together. Actually, I have it in one of the future slides, but I'll just show. Let's say I have a point like 1, another one, I mean, having 100. So there is a X, variable having a range 1 to 100, 1 to 10, let's say 1 to 10. And then there is another variable Y having a range 100 to, let's say 10 past 6. and one thing that is having a value, say 0 to 1. And then I'm having points of these three, like I have a point like 1, 100, 0. Then I have another point like 10, 10,000, 1. Like that, I've got couple of points in this XYZ coordinate plane and I want to compare them. So will these ranges impact my comparison in some way? Okay, I'll discuss this in more detail in the next turn. What will happen if we have this kind of a data? So let me stop here today. If you have any other questions regarding whatever we did, I think Shika has raised a hand.
Ma'am,
Can
just one, yeah, sure, one quick question. The example that you just gave, for example, there's a sales in India and there's a sales in US. So here, would that be considered as one variable, which is X, or would that be X, Y, X being rupees and Y being dollars?
Okay. So now, if you are generally, let's say you are interested to analyze the sales, then the sales, whether it is happening in your India, establishment, or it is happening in US, all is just sales for you. That is one aspect of it. However, for some business requirement, you could have sales in India being treated differently as sales in US. But if we are generally interested in sales, then all of them has to go in sales only. Okay.
So that would be one variable only.
Yes.
If we just want to monitor the sales.
Yes, that will be one variable only, and that's why we'll need to actually transform the data so that all of it comes in a similar unit, because all of them will be in different units, and so we cannot compare them directly.
Okay, thank you, ma'am.
Yeah, Yash, what did you want to ask?
Hello, ma'am. I am from GIS background. I use normalization technique for in a raster data to reduce the execution time of that raster data. So it is means it is possible to do that with Z-score also. We have a multi-band data like 13 to 14 bands for satellite image like Sentinel or Landsat.
Okay. So Z-score may not be, though you can apply Z-score, but Z-score is more meaningful when you want to have, some kind of ordered, ordering in the data. For example, as I said, that Z-score is very popular if I want to grade something. Let's say I have a set of marks and I want to derive some grades out of the marks. And so there's an inherent ordering in the grades, right? So we'll have A plus A, something like that. And so we want to look at what is the average performance. And that's why we use the mean, we subtract the mean. And who are the people who perform around the average? Who are the people who perform 1.5 times better than the average? Who are the people who perform 1.5 less good as compared to the mean? And accordingly, we decide the grades around the mean. So this is a very typical use case for Z-score normalization. So in raster values, probably it may not be a very good fit method for normalization.
Can you use normalization for reducing computation time for band operations or raster operation?
You can use normalization for a whole lot of purposes. You can reduce normalization to reduce the volume of the data as you are mentioning. And this is one use case that I'll be taking slightly later, but yes, you can do it to reduce the volume of the data, and hence it will require less time once normalized.
One more term we are using, like downscaling of the data. So normalization and downscaling are correlated.
Yeah, downscaling means that you are mapping it to some other lower range. So, or you are scaling it down. Let's say the value is range of values is some higher range. You want to scale it down to some lower range. So that's a form of normalization only. Okay.
Thank you.
Yeah. Okay. Any other questions? Yes, Sandeep, what did you want to ask?
Ma'am, my question is related to the binning of the data, which we discussed in the beginning. So once we're done with the binning, are we expecting that new data will come in and we will categorize them into the bins?
Yeah, see, once the bins are formed, you can always have new data coming in, and you
Yeah.
have to keep accommodating it in the bins. If it
Right.
gets accommodated in the bins, it's normal point. If it doesn't get accommodated, it may be noise.
Okay. So ma'am, when we are doing binning by means, right? Then how come we are evaluating that a new data is fitting into that bin or not? Are we again calculating the mean and deciding that factor?
No, no. Once we know what is the legitimate range, and once we form the bins, I don't know, there's some echo that's going on somewhere, but anyhow.
Maybe
So once we form bins, that's why I said bins are mostly static. Once they form, we form, they are there. That's it. Now, any new data is there, we accommodate them in the bin only. Until unless we have a, we have a new set of binning, that is another completely new thing. But once the bins are formed, we assume that the range of values that we are having is a legitimate range, on the basis of which we form the bins. Now, on the basis of the bins, any point will be accommodated, new point will be accommodated in any of the bins, like that. They don't change dynamically until unless we are using something like clusters, which are dynamic in nature, that are more dynamic in nature. Okay.
Okay, ma'am.
Okay. Any other questions, anyone?
Ma'am, do we have anything left in this data pre-processing and curation part, or is it done?
No, we have. I was hoping that we'll do it today, but I think we spent a lot of time discussing, which is also a very good discussion, I should say. So, in the next turn, I had hoped to finish this today, but a little part of it is left, not very, some part of it is left. So, I will cover that. And then I will be talking about, I'll be discussing some similarity measures that are very commonly used. This is what I will cover. Then I want to start with EDA. So I'm hoping that next weekend we'll be having some environment for doing hands-on, and then we'll together do EDA on one of the turns, and one of the turns I'll finish this stuff that I'm saying, the rest of this part, as well as some similarity measures and something related to EDA, like, the plots and all, some concepts related to that I will do in the first turn, which may be on Saturday, and the next turn I hope to do some hands-on. This is what I'm planning for the next week. Okay.
Perspective, what do you think about the pace of a task? Being slow, not up to the expectation that you wanted to do with. Any inputs on that?
Okay. So I don't know how to pronounce. Is it Mao?
It's
The
Mao Das. Yes,
Okay.
Mao.
Okay. So Mao, my observation is initially, any batch takes up some time to build up pace, because these are the few initial classes. They are also very important topics. And once you start once you gather some pace, then it is built up. So I would say it's a little less than what I expected, but it's okay. Usually in the beginning, it takes a lot of time, a lot more time than what I feel. And also another thing, it also varies from person to person, batch to batch, and all that stuff. So hopefully we'll be a little more faster in future. And it's okay to be, it's okay to go the way we are going right now. That's fine.
Ma'am, for the visualization part, which should we use, either Python, MATLAB, or Jupyter Books? So for the visualization thing.
So you can use this Matplotlib in Python. I mean, and you hopefully we'll have some.
Because MATLAB also has a AI complete library.
So Yeah, you can use anything that is of choice to you. It's fine with me, but the code I will be showing, it in Python. I won't be using any other thing because that's the most popular one and
So
everybody
the
wants to.
the way ahead would be, any cloud platform being shared by FutureNs, or we should be, using our own, Jupyter books, or like that,
Yeah.
Anaconda and all. So that from next lecture onwards, when you will be doing practicals, so at the same time we can also open our Python notebook
Yeah.
and do the
Yeah.
practicals along with you.
Yeah. Yeah. So usually what I had thought was that if we have a common environment, everyone can open his or her instance and do the same code at the time I take it. So that's a good way of looking at it. And that's what we are working at. I think Simran, would you have any comments in this regard that we had discussed the other day regarding a programming environment?
Yes, ma'am. The tech team is working on it. We should get back to you during this week beginning.
Okay. Okay. So hopefully we might have this. In case we are not able to have, then obviously each of you will be doing it independently on your own laptop, whether it's in the client server mode if that environment is ready. Otherwise, it will be all standalone, but the same code you all will be running concurrently with me. In case, I mean, that's what I expect, so that you can learn what we are doing. So that's the way ahead.
Okay, ma'am. That would be.
And normally you use Jupyter Notebook or Jupyter Lab only, right?
Yeah, yes, that's the
Ma'am,
most one.
ma'am, the Google Colab is fine to run that code, or because I
Yeah.
don't have that much capability laptop with us.
Yeah, so that's what I'm saying. I yet cannot tell you whether we'll be using Colab or what environment, because that is being decided at future ends. That's what Simran told right now. So next week, towards the weekend, we'll be more clear how we'll proceed with the hands-on. Okay.
Hello, ma'am.
Yes.
Ma'am, regarding the hands-on session, we are a very diverse group and a very curious set of group as well. Will we have, so there will be a lot of questions in the hands-on session. So will we have teaching assistants, or will we be divided into different batches so that all of our queries can be handled appropriately?
So regarding the code, as you all know that we expect that all of you have basic programming skills in Python. So therefore, the questions that we expect or I expect is pertaining to the content that is covered here. But if we start learning Python here, then we can go nowhere, right? So I will not be teaching you Python. I will be teaching you something on top of it. And otherwise, also you don't gain. Otherwise, you have to join a course that teaches you Python, right? And then you don't learn anything and nobody else learns anything. So the hands-on, all of us will be doing here parallelly. And I will be focusing on the concepts for which I will be taking the hands-on. Let's say if we are doing something related to visualization, then I'll be focusing on how to do the plots. But I cannot be teaching you. I mean, it will be difficult for me, though possible, to teach you, how to create a data frame. That I cannot do, right? If I do that, then we'll be nowhere. Then even 1 year will be less to do anything. So that background is expected. So you please, those of you, I think I assume most of you have it, but if you don't have, please do that. Please be familiar with the basic operations in Python, because we can't be teaching those for benefit of everyone.
Thank you so much, ma'am. That makes a lot of sense. Thank you so much.
Yeah, thanks.
Ma'am, this is
Request you to dictate the pace of our sessions, because you have no one other than you has the complete clarity on what needs to be covered and how we need to go about. So request you that you dictate the pace. We will tune ourselves accordingly. I think that would be best for the benefit of the entire class.
No, see, from my side now, I can be fast, but in the initial few lectures, it's okay to be a little slow, because right from the beginning, if you are not able to gather some foundations, then people tend to get lost. So maybe a few classes, a little slower pace may be fine. But in any case, you should not worry at all that initially if your pace is slow, then you might incur a loss on the contents. The coverage will be whatever has been thought of. Okay. So you will not lose anything, even if it requires taking a little more turns, or there are some buffer turns also that we intend to keep just to cope up with such issues. But don't feel worried. We'll cover everything, so you don't need to worry. I will slowly increase the pace also. Maybe after some few more classes, I'll be a bit more faster. Okay. And another way of being fast is that I can take all the questions at the end. That also I can do, but sometimes I feel that if you don't understand in between, then you don't understand at the end also. So I also take questions, but don't worry, Mom. We'll do everything that we need to do.
It's very reassuring, ma'am. Thank you.
Yeah.
Thanks a lot, ma'am.
Ma'am, for
Thank you so
next
much.
hands-on, if we need to do it on a local laptop, do you have any prescribed set of libraries or any Python version that we need to sync up? Otherwise, at times on runtime, it creates some issues, right? And we create a lag. Do you have any such that we can have this prepared?
So you just need to have a standard Python setup. You can use Jupyter Notebook or anything and have all the standard libraries that you usually use for such a class. Right now, I'm not doing any special code, and if I will do in future, I'll ask you to install and come. Okay. As of now, nothing special. We'll be doing the normal things. Right? Okay. Any other questions before we wrap up? So Shashank, I know that the pen I'm using is not a good pen. Actually, I have a digital writing pad. I'm just working to get it, next time. So I myself find it very difficult to write.
Yes, ma'am, because we can feel that there are so many hidden concepts which you want to explain, but due to this, you are not able to do so.
Yeah.
Yeah.
I will be, I'll be getting, it's probably on the way, so I'll be getting a digital this accessory, and that will help me to write on the screen. Okay. Okay, then I think if we don't have any questions, then we can break for today, and wish you all a very happy Sunday, the rest of it. Half of
Thank you,
it
ma'am.
anyway.
Same to you.
Thank
you, ma'am.
Anyway,
Thank you,
went.
ma'am.
Thank you.
Thank
Bye-bye.
you.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you. Thank you, ma'am.
Thank you, ma'am. Bye-bye.
Thank you,
Thank
ma'am.
you.
Have a
Bye.
nice day.
You.